All right. So tell us about Prime Day.
Wow, Prime Day is always exciting, and from the what I love about it is behind the scenes, the teams that keep all the Amazon infrastructure running, they spend months getting ready for this to make sure that all the different pieces of infrastructure are going to perform flawlessly. And I remember in the earliest times at Amazon, scaling. This is before AWS, and this is one of the motivators for AWS is that there was an actual spreadsheet that was passed around from team to team that you would basically say, here's your team, here's the servers that you have, how many do you need for the next holiday scaling season, and when do you need them? And each team would fill that in and pass it along, and there'd be some negotiation of timing and of exact allocation. And that was such an obstacle to scaling, and it was a big complicated thing that you have to do every year. And of course it's really hard to plan how much resources you need. And if you're innovating and you've got some new services, you never know how popular that part of your site's going to be and how much you need in the way of resources. So getting to this point where it's AWS powered and there's great things like auto scaling and serverless, it doesn't make it like effortless, but it means that it's a different kind of effort where a lot of the work that goes into it is more in the way of projecting and planning and making sure that each part works well and making sure that you understand the scaling characteristics. And so that when it happens, it's a matter of just watching the metrics, making sure that everything's heading in the right direction. If you see something not in the right direction, like what can I adjust before it goes from it's purely noticed internally to something that customers will notice. So it seems like every year we get better and better at this.
Yeah, the numbers are actually absolutely staggering, and every year you guys beat them by quite a margin. And what I find baffling, in fact, I struggle with it even internally, is just being able to predict the demand, both on the minimum requirement side and setting a cap, because you kind of don't want, like, there's a fine line between letting something run away because there's some error somewhere, and you've suddenly got 100 or 1,000 instances of something running, and suddenly a bill is kind of super bloated, versus actually looking at something that is pure demand and reacting to it responsibly in an elastic manner. How do the teams go about doing that? Is there any light you can shed on that exercise that happens at Amazon on being able to do that estimation?
Yeah, so one thing that I know that the teams like to do is that they generally like to establish expected ranges for a lot of the metrics and say, well, in general, we know that this particular metric will be between low bounds and high bounds, and they'll set alarms on either end. And one of the things that I know that we used to talk a lot, I don't know if this is still the case, I'm guessing it still is that in a distributed system, it generally doesn't fail all at once. It will tend to start slowing down, and instead of 100% of the things working, 99.99% work, and then 99.98 and so forth. And if you can detect those tiny like failures and retries and the situations where maybe a queue is getting slightly longer or a buffer is getting full, those are things that you can alert on very early and take protective action or preventive action before it becomes customer visible. And the ultimate metric that we watch on the retail side is the number of checkouts per second. So that's an awesome metric because that means everything else has to work. The website has to be functional. It has to be able to display content to the users. It has to be able to accept things being put into the shopping cart. The checkout process has to work. Probably 1,000 other things I have no idea actually have to be there, but to the point where you've actually successfully done a checkout and your order is now in the system and we're getting ready to do the fulfillment. So many pieces have to work that watching that number turns out to be a great early indicator of something else might not be right. Now, we have a couple of, I think, almost unique advantages that help us. we've been doing this for a really, really long time. So we have expected values on upsides and downsides of where these metrics should be. So it's very easy to say, well, where was this yesterday at this time? Or during the last Prime Day peak, where are we comparatively? I think that having that long history is really helpful. What was my second point? The second one I think is more important. We're running at such a scale that the numbers really make a difference. I think this is a challenge if you're not at world scale and your numbers are not millions, billions, trillions. We even have things I think we measure in quadrillions sometimes. When things are that big, the math works out and trends become really visible. If you're dealing with ones and tens and hundreds, you probably have to have a slightly different approach because the statistics aren't as accurate or as helpful to you.
True.
Well, looking at your blog post, looking at the SQS, so this is 70 million transactions on SQS per second. SES was 33,000 emails per second. Let's see, 152 petabytes to EBS. It's some huge numbers. 5,300 Aurora database instances for 288 billion transactions. So yeah, by the law of large numbers, you will see every statistical phenomena that's remotely present in the data will appear.
Exactly.
How do the teams organize themselves to tackle? I mean, the Amazon system is presumably a very, very complex system with, I mean, just given the number of databases and stuff that are being used, the number of queues that are probably getting used over here, this is a very, very vast and complex system. One of the challenges of a complex system like that is that you're likely to get overwhelmed by the number of metrics that you're looking at the lower level. It's great to have that one metric that gives you an early indicator, like you said, number of checkouts. But when you get into the next level, when something does go wrong, there is a very high likelihood that you could get overwhelmed with just the number of alerts and alarms going off all over the place with that many services that are interlinked or which have a strong cohesion of sorts, trying to get everything working. So how do the teams organize themselves in terms of tackling a problem when there is a problem?
So my understanding, and I haven't been operational for a really long time, but each team owns a particular service, and we always call them a 2-pizza team because we try to keep them small enough that 2 pizzas of some arbitrary size with arbitrarily hungry staff on there would be happy with. But the idea is that each of these small teams owns some very particular important microservice, essentially, that helps the site to succeed. And so it's up to that team to figure out what that service should be, build it, figure out what metrics to watch and to track and to alarm on all those metrics, and to make sure that they know who their customers are and who their dependencies are, that all the customers that are counting on them. So instead of one, like, you used to see these pictures of these like ISPs and telecoms with these gigantic rooms and big screens and the central operations center.
Yeah.
I don't think we have one of those because that kind of assumes this central level of control versus we're saying if each of these individual teams does their part, then we're much more closer to success than having some central team that somehow has to monitor everything. Now, clearly there are situations when something does go wrong and multiple teams are involved. And when that happens, a ticket is cut. Usually it's actually an automatically cut ticket because some metric went outside the bounds and it says, well, this metric went too high, too low for 5 successive checks. Let's cut a ticket. And then the idea is each of the teams that might have some involvement in there, they have to actually log into a shared phone call. And from there, they start very methodically working through and saying, does it look like this? Does it look like that? And again, because it's a distributed system, it's sometimes in the connection between the systems rather than is any particular thing failing? Well, not one thing is failing, but when you connect these two things together, They're operating in this interesting way that we've done our best to predict and forecast, but sometimes there's still surprising dynamic behavior. But things that you keep identifying and getting better and better at over time to understand.
That sounds pretty interesting, but at the same time scary to have that distributed and a setup and still have everything work. It's got to be a really well-oiled machine.
It's well-oiled. One thing that I think is in our favor is that we try really hard to learn from every event, and there's this Amazon, not tradition. It's deeper than a tradition. It's a best practice and required, is that anytime something goes wrong, the first thing we do, of course, is get things back on track and restore service for our customers. But then someone is appointed the owner of a document called a COE, a correction of errors. And the idea is that you go back into all of the log files and you say, okay, what went wrong? And sometimes you put together almost a millisecond by millisecond recounting of this happened, and then this happened, and then this queue got a little bit too high, and so we tried to scale, and then this other thing happened. And then you basically, without pointing any fingers at people, you're always pointing, you're saying, well, this system didn't work and this alarm didn't fire. You say, first, what went wrong, and what do we need to do to make sure that this particular thing can never, ever happen again? Sometimes that is involved with just simply adding more alarms. You would say, well, this particular situation, we didn't even know that this was a thing to monitor, but let's make sure we monitor it the next time around, and we'll just add some more alarms and alerts. Or it might be, well, we discovered this new behavior and we need to do some more engineering work to get around it. But at any point after one of these situations, remedying that technical issue, it becomes the highest priority for the team. So in any of we've had a few very high profile, but fortunately very rare visible events over the years. At the point when we figure out why did that happen, making sure it can't happen again becomes the very highest priority for the team, where they will say, we're going to push everything else on our roadmap. We'll just push that a bit into the future. We're going to make sure that first one, I'm not saying it's acceptable, but it happened. But doing it a second time, that's for sure not something we would allow. Now, the iteration of this process over years and years and years means that we keep building more resiliency into the system, which is super important. But the other cool thing is that these COEs are numbered. And when you start talking to our principal engineers, and a principal engineer is someone with decades of experience and is basically like the equivalent of a director or a VP, but they still get to build and architect systems. The more notorious and the COEs where you can learn the best lessons, they've got numbers that you listen to these principal engineers and they're like, oh, do you remember 253? Oh yeah, that wasn't as bad as 155. But yeah, but we learned a great lesson from 157, which we now tell everybody to use that. And it's fascinating to see how much we've learned over the years. And these are hard-won lessons that we don't forget, and that each one of these is going to help us to do something better and better over time.
That sounds like more than a best practice. It seems very ingrained in the Amazon culture.
It's fascinating to read them. Even my best days of actually building stuff with code are long, long, long past, but I can still read these things and understand them and say, we've got really sharp people building and running these. And another aspect of it is that once a team builds something, they also have to run it. We're not kind of like this old school model where there was this team of engineers who built things, and in the engineers' heads, everything was perfect. And then they'd hand it off to these poor folks over in operations who had to deal with whatever stuff was thrown their way and try to actually keep it running. And of course, there was plenty of finger pointing, and issues with operational issues didn't always get back to devs. So the way we like to run things is that the same people that built it, they're the ones who are actually going to be on call and to make sure that when something breaks, they're the ones that have to dive deep and figure out what went wrong. I still remember my first day at Amazon, and I had lunch with my manager, and he hands me a pager. I don't think we use pagers anymore, and probably the audience doesn't even know what pagers are.
Yeah.
He hands me a pager and says, "You are the secondary on call in 2 weeks." And the implication of that is, oh my gosh, I'm going to be responsible for keeping the system running. I'd better actually understand how all this stuff works. And,
Right.
you know, if at the point when you go from being secondary to primary, and during your not quite a shift, but when you're the on call,
Yeah.
your pager goes off. You're supposed to log in and within like minutes know the system in depth. Say, okay, well, this is the problem. We need to actually take progress toward remedying this.
Yeah.
I was happy to not have that pager anymore, by the way.
Well, just thinking about, I'm still thinking about that 70 million messages a second. So for every 13 seconds that your backlog grows by 1 billion,
Mhm.
that's you really want to think quickly there.
The numbers are staggering.
That brings you to another question around the elasticity. So this is now more on the AWS side, less on the Amazon side. I remember a time when the data centers were still growing, coming up, where the capacity planning team had a big role to play. There was one time when I was just trying to figure out how many Spot instances I could get, and I tried to launch 100 X132 XLs. And I got a call from the team saying, "What the hell are you trying to do? Let us know at least a month in advance so we can plan out this experiment that you're running or whatever." How much of a dent does this Prime Day workload make on the AWS side in terms of the capacity planning exercise and so on? Like, is it like, okay, it's big enough that capacity planning has to get involved, or is the AWS size or the scale large enough that it doesn't really matter? There's enough elasticity built in.
I'm not privy to that information, but I think we're now at your latter point where we've got so many customers with so many different use cases, and some of which are on just different utilization cycles, and some of our customers are using Spot instances, and so if we were to need a lot more capacity, then that can presumably come from Spot instances. But what I've heard, and I don't know this directly, is that we are probably not the biggest consumer of compute capacity around.
Got it.
And also, this is a spike versus someone stepping up and from zero saying, I now need this much brand new capacity. We've got all this awesome historical data that's going to help us guide us through these times.
And some very good predictive tools to use that, and some very smart statisticians.
Indeed, and a lot of that we've also made available to our customers. So we do have predictive scaling that uses historical data. I know we just recently launched something new that, in addition to doing the predictive scaling, it publishes some metrics that are kind of like, it's kind of tattling on itself to saying, this is how well or how not well I did at predicting your need for predictive scaling. Like, did it too much, too little, and so forth.
That's really cool. Well, we want to transition to the Graviton segment really soon, but just one last follow-up question. What did everyone get for Prime Day?
I went ahead and ordered a whole bunch of PLA spools because they were available for. I had I think 4 different colors earlier. I have expanded that to now nearly 10. So yeah, I bought a whole bunch of PLA spools.
I was much more restrained. I only bought one because I think I've got about 20 colors here right now. So, I've got a lot.
It's got a lot of spools.
I'm in a phase of life where I'm trying to own less things, not more. There's always a lot of stuff I'd like to have, but I'm like, do I really need that or not? And kind of adding complexity only reluctantly.
I can understand that.
I did get a Fire TV for a dashboard and calendar. It's off to the side here. We're going to do a behind the scenes episode in a couple of weeks, so I'll show that. All right,
that's awesome.